Welcome to the Definitive Explainer team. Look, I know you're all completely exhausted from endlessly copy-pasting boilerplate AL code, right? So today, we're embarking on a massive shift. Think of me as your senior architect guiding you through a total transformation of your day-to-day work. Today, we're diving into the playbook for building your very first autonomous ERP skill. We are finally stepping out of the weeds of manual coding and stepping up into the role of true systems architects. Let's get right into it. Our new reality really boils down to this one idea. The era of manual ERP development is definitively over, period. We're replacing what some call vibe coding with deterministic programmatic instruction. The days of endlessly typing out that same boilerplate over and over, dead, completely done. We're moving entirely away from amateur, one-off prompt engineering, and we're shifting our focus to structured, highly repeatable Claude skills. Here's our playbook for today. 1. End of the boilerplate era. 2. Configuring your MCP foundation. 3. The skill creator protocol. 4. Preventing schema hallucinations. 5. Human-in-the-loop checkpoints. And finally, 6. Benchmarking AL code quality. Let's kick off step 1. Section 1. End of the boilerplate era. If you've spent literally any time in Business Central, you know the cognitive tax of manual table extensions. It's draining. But today, we put an end to that. Moving right into Section 2, configuring your MCP foundation. To actually bridge the gap over to Microsoft Dynamics 365, we use the Model Context Protocol. So here is exactly how we set up that foundation. The Model Context Protocol, or MCP, is the absolute crucial bridge that turns Claude from just a general AI assistant into a highly operational ERP agent. Now, you must define some mandatory connection parameters to securely hook into Microsoft Entra ID. You need your tenant ID for environment discovery. You need the environment name to define the agent's scope. Is it sandbox? Is it production? Then, obviously, you need the specific company, the configuration name to actually select the active tool set, and finally, the dynamic tool mode. And honestly, that toggle is brilliant. It just bypasses client-side tool limits entirely. This whole setup ensures that every single action the AI agent takes is performed under your specific identity and permissions. It creates a completely bulletproof audit trail. All right, Section 3, the Skill Creator Protocol. This is where we start the actual build phase. This is the fun part. This is where we encapsulate your procedural knowledge into modular Claude skills, rather than relying on bloated system prompts that just eat up the context window and inevitably cause instruction drift. We follow a rigorous, 3-step iterative cycle here. Step 1, define your schema logic with concrete examples. Think adding a loyalty program field to a customer table. Step 2, integrate references. This is where you actually include your schema standards and boilerplate templates to anchor the agent so it doesn't go off the rails. And then step 3 is deployment using the init_skill.py script. Running that generates your skillmd directory structure, which gives you a perfect, clean skeleton to populate with specific instructional narrative. Section 4. Preventing schema hallucinations. As junior developers stepping into architecture, you absolutely must avoid the trap of unanchored AI inventing database fields that don't even exist. Look, the amateurish zero-shot approach, where you're basically just asking the agent to build from scratch, inevitably leads to schema hallucinations and failed joins. It's a mess. Our enterprise standard requires reference-anchored skills. By injecting static DDL files, like a schema_standards.md file, you're providing a structural blueprint. You are giving the agent a few-shot learning reference. It acts like a heavy architectural anchor, so the agent never deviates from your established naming conventions or object ID strategies. No more guessing. Moving to Section 5, Human-in-the-Loop checkpoints. Because in high-stakes environments, no AI agent operates without strict developer oversight. And that brings us to a massively critical step in your workflow, the implementation plan. Before the agent commits any changes to the ERP or the codebase, it absolutely must generate this markdown artifact. It details exactly which objects will be created or modified. You, the human in the loop, must review the logic, check the vibes, and give explicit approval. Literally, nothing gets executed without your signal. You are the gatekeeper. To support your orchestration, we enforce some really robust enterprise guardrails and debugging tools. Through least privilege skill scoping, a database skill cannot accidentally run shell commands. Simple as that. But pay special attention to stop hooks. These are bash scripts that intercept the agent to block responses containing empty promises. For example, if the agent says it will remember a detail but doesn't actually execute a database write action, the stop hook catches it right there, blocks the response, and forces the agent to actually perform the action. Coupled with granular execution logs, you have total 100% visibility into every single API payload. Finally, Section 6, Benchmarking AL Code Quality. In our modern workflow, we don't just look at the code and guess if it works. We prove it through empirical diagnostics. Our success criteria here is super strict. We target a greater than 90% success rate without any compiler errors across automated table and page extensions. We expect our production-ready skills to hit this mark consistently, leaving only a 10% acceptable failure or compiler error rate during the drafting phase. That is the bar we're setting. Now, to actually hit that 90%, you need to track specific performance metrics. First, monitor your time to first token. You want to keep it under 500 milliseconds for high interactivity. Nobody likes waiting. Next, you need token throughput, greater than 50 tokens per second, so you aren't just sitting around waiting for complex LL files to generate. And honestly, most importantly, agent efficiency must be above 70%. This just means the ratio of productive work to coordination overhead is lean. By tracking these metrics in your HTML reports, you can easily identify hot paths in the agent's logic and continually optimize your long context prompts. So, I want to leave you with this final thought. Are you ready to stop typing boilerplate and start engineering ecosystems? The tools are right in front of you. By mastering MCP configurations, leveraging the skill creator, enforcing those architectural anchors, and relying on empirical benchmarks, you are no longer just writing code. You are building self-optimizing systems. Take this playbook and set up your first autonomous skill today. Because think about it, if you aren't building self-optimizing systems now, what exactly will your role look like in 5 years?